This is the first lesson for Unit 1 for 8th grade accelerated math. In this lesson, we'll be talking about order of operations mostly. If you feel like you need some additional review on doing order of operations, I have an additional video that I will link that you can watch to help you review those concepts. So in this video, we're just going to go through and do some examples and talk about some different parts of order of operations, and then a couple of other things that have to do with that. So order of operations, the reason why we have it is because there has to be some rule. Otherwise, we would be able to look at a problem and everybody do it differently. So if you skip on down to number 1, just for example, if there were no order of operations, somebody might say, well, I'm going to do that first, and then get 80 divided by 3, and then you could say it's 80 thirds, or you could get a decimal approximation. And then somebody else could say, well, I'm going to do that differently. I'm going to do the 75 divided by 3 because that works out nicer. So I'm going to do 5 plus 25, so I'm going to get 30, which is not equal to 80 over 3, by the way. Okay, so we have order of operations to give us a structure for how we do math problems, and so everybody accepts that. So we have something called GEMDAS. Now you might have heard of something like that called PEMDAS. And so if you're familiar with that, then this is not going to be hard. GEMDAS with a G instead of a P, we're going to use that because it's a little bit more broad. And so the G stands for grouping. And so instead of just saying we're going to do parentheses first, it means we're going to do all grouping symbols first. And grouping symbols can be parentheses. They can also be square brackets. Sometimes they can also be a fraction bar. And so we have different types of grouping ways that we write or we'll see equations. And so we're going to do those first always. The next thing that we're going to do, you may know, is exponents. And so exponents come next in the order of operations, and the order of operations just gives us priority. So exponents have priority over adding and subtracting, multiplying and dividing. Okay, the MD, they go together, and that's going to be multiply and divide. And so if I ask you which one of those comes first, does multiplication always come before division? So think about what you think the answer to that question is. And then let's skip to the AS for addition subtraction. So again, same question, does adding always come before subtraction? Or is that something that maybe it does sometimes, maybe it doesn't other times? How do you know? And so think about if you know the answer to those questions. So the answer to the question is that multiplying and dividing and adding and subtracting, they're going to go from left to right. So if you have a division problem on the left, then it's going to come before the multiplication problem on the right. And same with adding and subtracting. So it just matters which one is left and which one is right. All right, so now to practice the order of operations, we're going to just do some of these problems without a calculator. And I'm going to go quickly through some of them. I'm not going to do all of them, but I'm going to go through some of them and just talk about how I want to see the problem on your paper and how you should be able to do this without a calculator. All of the numbers are small enough, and I've written the problem so that it's not that hard to do without a calculator. So I already kind of did number 1. The way that I did it secondly was correct, where you do the 75 divided by 3 first. And so what I want to see on your paper is I want to see each step. Okay, and so that's showing your work. That's showing that you know what the process is. If we go, let's just skip to I'm going to skip around a little bit. So if I go to number 3, I see that I have parentheses, and so they come first. So whatever comes inside the parentheses, I'm going to do that first. So I have 5 squared plus 3. Well, this is an exponent, so I have to do that first. So I'm going to have 25 plus 3 in parentheses divided by 2. That's my first step, and so I'm going to write it like that. The next thing I'm going to do is finish out my parentheses. So 25 plus 3, and that's 28, and then I've got divided by 2, and then that's 14. If I go to something like number 6, that has a couple of different exponents. It also has parentheses, so I need to be really clear about what's happening first. The parentheses are going to tell me what to do first. So 8 minus 2 is 6. And so I'm just going to change that, and everything else is going to stay the same. The next thing I'm going to do is focus on my exponents. So 6 squared is 36, and 4 squared is 16. And so that's my next step. Now, for the next thing, what do I do first? Do I do 36 divided by 9 or 9 plus 16? One thing you need to be really careful of is a lot of people think, well, I'm going to do 36 divided by 9 first because it's easier or because it works out better. That is not a reason why. Okay, you can't make a decision based on what looks better or which looks easier. So you need to make sure you go by the rules. Now in this particular case, since division does come before addition in order of operations, we are going to do that first. But you need to make sure you understand why we're doing it first and not just because you know what 36 divided by 9 is. Okay, so the answer to that is 20. Okay, I'm going to do a couple more. If I go up to number 2, I've got these square brackets, and we use these if we already have a set of parentheses, and so they're called nested grouping symbols, like one's nested inside the other. And so what happens is you go to the innermost piece, and so this 3 minus 2, that's going to come first. So I'm not going to do anything else except for say that that's 1. Now, when you're doing this without a calculator, it's really important that you write these steps out. Number 1, I need to see what you're doing so that I know you're not using a calculator. But number 2, you need to understand what the process is in your own head so that you're able to do these things, because eventually what happens is we do these same things, but we have variables instead of just numbers. So we have to know what the processes are. Okay, so now I'm down to 7 times 3 and then divided by 3. So that's 21 divided by 3, which is 7. Okay, now number 4, I'm not going to do that one, but notice that there's nested parentheses also, and so you're going to do this one first and then figure out what that is and then do all of this next and then bring in the divided by -4. Now the ones that I don't do, you're going to want to look on the link that's provided on Canvas, and I take you to the notes. And the notes that I have filled out for you, they have all of this stuff already written in, and so anything that I skip in my video, I will cover in the notes. It will be written down and it will be step by step so that you can see how to do everything. And then if you have additional questions, you want to come and ask me. Okay, the next one we're going to do is number 5. Now number 5 can be kind of hard because there's some things there that you may not really be aware of. So first I'm noticing nested parentheses again. So I'm going to do the 2 minus 6 first. So 2 minus 6 is -4. And so I'm not going to do anything else except for just write that. Now, what does an exponent mean? So I'm just going to kind of take a little side note here. An exponent means that it's repeated addition. Okay, so that's what it is. And so it's like if I have, 3 times 3 times 3, an easier way to write that is 3 to the 3rd power, which is not equal to 9. Okay, so make sure that you understand that that's not what we're doing. It's 3 times 3 times 3. So if I have -4 and it's in parentheses to the 2nd power, that means I'm going to do -4 times -4. Now we're going to talk a lot more about this idea right down here. Okay, but right up here, I'm just going to go for -4 times -4 is positive 16. Now if you do that wrong and you get a -16, then your whole answer is going to be different. So you need to be very careful. And so down here where I put the green star, when we go through that, you want to make sure you pay really close attention. So I'm going to have 16 plus 2 is still in my brackets, and then divided by 6. And then so I'm going to do inside my brackets next, so 18 divided by 6, and that's equal to 3. Okay, so try number 7. I'm not going to do this one with you, but I will tell you that it's got something similar to number 5 with the exponent, and so try number 7 on your own and just make sure that you get the same answer. And you can check that on the notes. Number 8, you've got a multiplication, a division, parentheses, and addition. So you've got a lot of stuff going on. What's going to happen is you're going to do the parentheses first. So 8 times 3 plus 6. Please avoid the temptation of just doing 8 times 3 because you know what it is. A lot of people do that because they see it first and they're like, oh, I just know what it is, so I'm just going to do that. Don't do that. Okay, the next thing I'm going to do is now I'm going to do this because it's next in the order of operations, not just because I see it first or I already know what it is. I'm doing that because it's what's next. I don't need to write the parentheses around 6 because it's not doing anything now. It's not separating it or anything, so I can just say 24 plus 6 is 30. So again, number 4 and number 7, I would encourage you to try those on your own and then check them with the notes. Okay, the next part of this is applying order of operations to exponents and what this means. And so I want you to just pause the video for a second and I want you to fill in what you think this is. Okay, so what do you think -1 to the 1st power is, -1 to the 2nd power, and how is that different than in the 2nd column? And then start the video again. Okay, I've got the charts filled out, and this is what this is. And so if you examine the differences, if you look at what I have in green on the right, because of the parentheses, everything in the parentheses gets repeated this many times. Okay, oh, it looks like I erased something. So that's what's happening right there. You've got -1 times -1 twice. How is that different than what I have right over here? Notice that in this one, if I have -1 to the second power, exponents come first, and the 1 is just being multiplied by a negative, and so it's 1 that's being repeated, not the negative. If you want the 1 to be repeated, then you would have to do, or sorry, if you want the negative to be repeated, you have to put the parentheses around it. And that's a really important distinction and something that people struggle with over and over and over. So on these right here, this is equal to -1, this one is equal to -1, -1, -1. All of these are equal to -1. Over on the right, this one's equal to -1, this one's equal to +1 because -1 times -1 is positive. -1, +1, -1, +1. So you notice a pattern there. So pause the video and think, how could I predict? Do you know what -1 in parentheses to the 27th power is going to be just by the pattern? Okay, what you should have seen and noticed is that if the exponent is odd, then you're going to have a negative for your result. If you had -1 to the 20 or 208th power, it's going to be +1. Okay, so positive versus negative depends on the exponent when you have parentheses. When you don't have the parentheses, it's always going to be that negative because the negative's only there the one time. So that whole idea is really important, and we'll talk about this a lot more as we move forward. But on the next page, what I want you to do is I want you to write 2 observations that you made or that I pointed out or that you observed. And so pause the video and write 2 sentences about 2 things that you noticed. Okay, I've written 3 possible things that you could write. These are not the only correct answers, but they should go along these lines. Definitely number 1 is something you want to notice and make note of. Number 2, the 2 things I have there, they're kind of the same thing, just saying it different ways. And so you might say it different ways. All right, the next thing that we're going to do is we're going to go into some vocabulary that may be new or unfamiliar. You've probably heard these terms before, but you may not really know what they are. And so we're going to talk about terms, like terms. I'm not really going to talk so much about factors, but then coefficients and constants. And I may have to continue the last part of this on a separate video because I'll run out of time. Okay, so let's talk about some definitions. So first off, an expression. An expression is not the same thing as an equation. Okay, and a lot of people think that they're interchangeable. In fact, there was a time that I used to think they were the same thing. But if I have an expression, that would be something like x plus 2. You can't solve that, and you can simplify it, but you can't solve it. But then if I say that x plus 2 equals 5, now it's an equation, and I can solve it. So an equation has an equal sign, an expression does not. And so that's the distinguishing factor. And an expression can be anything. So these are all expressions. They can contain numbers, variables, and operations like add, subtract, multiply, divide. All of the problems that we saw on the previous page, the 1 through 8, those are all expressions. Okay, so all of those would be expressions. Okay, now the next one is term. And so a term is a single number, variable, or both. One or more terms that are joined by addition or subtraction, multiplication, or division is called an expression. So this is one term, okay, and this is one term. And that's joined by multiplication. This is a term, that's division, okay. And then if I have 2 of these, if I said like 8 plus 6x to the 4th, that would be one expression with 2 terms. If I said 8 plus 6x to the 4th minus 4h divided by 9 plus y, that would be one expression with 4 terms. So those are some examples of that. Okay, the next thing, and this is something that you've had practice with before, is like terms. Like terms are terms that have the same variable part, raised to the same power, so all the variable parts have to match. So if you look at what I have there in examples, the 6cd to the 4th and 8cd to the 4th, because the cd to the 4th matches, they are like terms. So So it's kind of like if I have an apple plus 2 apples, I can add those together and I have 3 apples. Now on the other hand, if I have 1 apple plus 1 apple pie, and I add it together, I have 1 apple and 1 apple pie. Even though they might be the same, they're not exactly the same, and so I can't add them together like that. And so that's what I have here. So I have these like terms. And so if you have like terms, you can add them or subtract them. You do not have to have like terms to multiply or divide. Okay, the next one is a coefficient. A coefficient is the number part of a term. So for example, in 6cd to the 4th, the coefficient is the 6. In the expression r squared, the coefficient is 1 because there's a 1 right there. And so we see coefficients all the time. We're going to do some practice with that. And then the last one is constant. A constant is a number that does not have a variable, because a variable means that things can change. But a constant is like a number like 5. That number is the same no matter what. It's not going to change. If I had a variable with it, then 5x could be 25. If x was 5, it could be 100. If x was 20, it's going to depend. But if I just say 5, everybody knows what that is. So these are examples of constants. Okay, I'm going to end this video and continue the rest of the lesson on the next video, so please join me there.